Biot-Savart's law. हो राहिलंय but तो छोटासा topic है. So see, yesterday's topic we have seen about the torque on a current loop, right? And the value or the formula for this torque is tau is equal to N I A B sine of theta, right? Where N is the number of turns, I is the current flowing in the wire. जे पण काय दिलेले coils or wire. A is the cross sectional area or the area of the coil, area of a single turn. B is the magnetic field and theta is the angle between current and magnetic field. ठीक है? Then moving coil galvanometer बघितलं, that deflection is proportional to the current where N, A, B and K are constants. So the formula is phi is equal to NAB upon K into I. So from this formula you can conclude that the phi, that is deflection of a moving coil galvanometer, is directly proportional to the current flowing in the coil, where N, A, B and K are constant. Again, N is number of turns in the coil, A is area of the coil, B is magnetic field that we have provided. Horseshoe magnet आपण connect करतो, radial field create करायला, the field is compulsory radial, and the denominator is K, that is torsional constant of a spring. Okay, how will it show the deflections or the torque will produce in it? Next was the magnetic dipole moment. So in electrostatics we had electric dipole moment denoted by P bar, right? So P bar is equal to Q into 2L, and that tau is equal to P bar cross E bar. So this was in electrostatics. In magnetostatics, this dipole moment is denoted by mu, and the value is Q ऐवजी ते असतो I, current, and instead of length here it is A, that is area, and it can be for the number of turns. So in magnetostatics or in magnetism, we have magnetic dipole moment denoted by mu, and its formula is N into I into A. Number of turns, current in one turn, so we have to multiply it by number of turns. And A is the area that is usually given. Okay, and torque in this case is given by tau is equal to mu bar cross B bar. So electric dipole moment is replaced by magnetic dipole moment, and electric field is replaced by the magnetic field. Clear up to this? Okay. Electrostatics मध्ये होता the potential energy related with that electric dipole, it will stored inside it in the form of a potential energy. आणि potential energy चा formula सांगितला होता, UE is minus P bar dot E bar. होता हा formula, that is electric dipole moment and electric field चा dot product. So dot product after expansion will give you the term cos theta, right? Okay, so that will be minus P into E into cos of theta. So in similar manner, you have in magnetostatics or magnetism, UM is minus P ऐवजी काय आहे, mu bar dot B bar. So it will be minus mu B cos of theta. This is the potential energy stored in magnetic dipole moment, that is minus mu B cos of theta. Clear? Now we will see the two cases for this theta, where theta is the angle between dipole moment and the magnetic field. Now the first case is if this theta is equal to 0, that is mu bar and B bar are parallel. Am I right? So if this is mu bar, then this is B bar. So between this mu bar and b bar, there is angle 0. So our first case is if theta is 0, this potential energy will be minus mu into b, and cos of 0 is 1. So it will be minus mu b, that is its minimum value. And the second case is if this is mu bar and this is b bar, that is this both are Kumar, hello. Okay. Yes, these are anti-parallel. That is your theta will be 180 degree. Laksha there so. So theta is equal to 180 degree, and this u, that is potential energy, will be 180 ka as to cos 180 minus 1 minus minus will be plus. So it is mu into b. So it is maximum. Me to minimum ka lila because it is negative. So when your magnetic dipole moment and magnetic field are parallel to each other, then your potential energy is minimum. And if these two are anti-parallel, then your potential energy is maximum. Value is minus mu b and plus mu b. What if these are perpendicular? See, the two cases were, one is parallel, second is anti-parallel, minimum and maximum. What happens if they are perpendicular? 0, because cos 90 is 0. ठीक है? Clear with these two cases? नसूच शकतात. म्हणजे energy stored नाही होणार आहे. That will be 0. So you can conclude from these two cases that when the potential energy is minimum, when it will be maximum, what are the two cases? Either it is parallel or anti-parallel. What is its minimum value? At the same time, what is its maximum value? They can ask you any question by turn, twist, anything in the MCQ. ठीक है, but they direct विचारतात what is the minimum value of the potential energy in magnetism? That is minus mu b. ठीक है, and the case is that is parallel. ठीक है, maximum is mu b, case is anti-parallel. Clear है? Now the very important and the next topic is our Biot-Savart's law. ठीक है, आपण फर्स्ट लेक्चर पासून असं बघतोय we are studying the magnetism by comparing it with electrostatics. ठीक आहे, इलेक्ट्रिसिटी. सो इलेक्ट्रोस्टॅटिक्स मध्ये एक लॉ होता ज्याला आपण म्हणत होतो कुलम्स फोर्सच म्हणू शकतो आपण, दॅट गिव्स यू दी इलेक्ट्रिक फील्ड ड्यू टू दी चार्जेस. इलेक्ट्रिक फील्डचा फॉर्म्युला 1/4πε0 q upon r square. That electric field was produced by a very single charge, right? But in magnetism it is not possible that monopole exists. So kadis honar nahi. So obviously monopole nahi hai, and here magnetic field will be due to the current and not due to the charges. Okay, so tikde every time we had constant 1/4πε0. So here we will have every time the constant, the new constant introduced hote as, and that constant is mu naught upon 4 pi. तिथे होता 1/4πε0 and its value was 1/4πε0, 9 into 10 raised to 9, and epsilon naught into minus 12. Here mu naught upon 4 pi will have the value 10 raised to minus 7 only. There is no number. ठीक है, so कधी कधी असं होतं what is the value of mu naught? So mu naught will be 4 pi into 10 raised to minus 7. You just have to rearrange this. Okay, so if it is mu naught upon 4 pi, the whole value will be 10 raised to minus 7. Clear itparanta? Now what is this Biot-Savart's law? Okay, for Biot-Savart's law is your magnetic field due to current. Obviously lessons नाव पण तेच. So exactly आपण आता त्या पॉइंटला आलेलो आहे. So for this तुम्हाला काय माहित असणं इम्पॉर्टंट होतं, रेस्ट ऑफ द टर्म्स यू हॅव स्टडीड ऑलरेडी. ठीक आहे, सो दिस इज मॅग्नेटिक फील्ड ड्यू टू द करंट. सो लेट्स कन्सिडर ए वायर. This is the wire of arbitrarily shaped. Generalized Biot-Savart's law बघतो. Then we will consider two cases, that the wire is straight, it is infinite, semi-infinite, and finite, and arbitrarily shaped, whatever. So we will see only two cases from all along this. This is the generalized format. So if this is my wire of length, let's say capital L, the current I is flowing into this wire, and I have to find out the magnetic field at this point, let's say P, due to the current flowing in this wire. So at point P, magnetic field due to this whole current will be different at various different points, right? So the total magnetic field will be the summation sum करणार आपण. पण आपण sum नाही करत, we will integrate the function. Why integration? Because this current is everywhere and it is continuous throughout. Also the length is continuous throughout. So summation नाही करू शकत, we have to integrate because our summation is a continuous summation. ठीक है? So initially we will consider this much amount of a length. Let's say this small amount of a length as dl, as the whole length of the wire is capital L. We will find out very small amount of magnetic field due to the small amount of a length at the point P. And the formula is given by dB is equal to mu naught upon 4 pi I into dl into sine theta divided by r square. This is your formula or the value of small magnetic field due to small length element in this wire. I will introduce you each and every time. ठीक है? dB small magnetic field. Mu naught upon 4 pi constant, because here तिथे epsilon naught होता, that is permittivity of medium. Here permeability matters. And what is this permittivity, permeability? It is given in your book. It is well explained in this NCERT books. खूप छान explain केलेलं आहे. ते पण एकदा वाचून घ्या. Mu naught upon 4 pi is your constant. It is constant throughout. If medium is changed, तर mu naught ची value ते देतील काहीतरी. I is current flowing in the wire. Current छोटा छोटा amount नसतो. Current will be the whole. Current ला parts नाही करू शकत आपण. DL parts करू शकतो. Due to small length element, this much amount of a length, it will obviously contains the whole current, that is I. So this DL is small amount of a length element. Now the next is sine theta. साइन अँगल घेतलेला आहे बिकॉज तो ऑपोजिट साइड वरती डिपेंड आहे. सो सपोज इथं थीटा तर ऑपोजिट साइड इज लेंथ, त्याच्यावरती डिपेंड असतो म्हणून साइन थीटा इज. नेक्स्ट व्हॉट इज दिस थीटा? थीटा काय असेल? थीटा विल बी theta is the angle between कशा मधला angle असेल? Actually theta is the angle between the position of this point or the distance of this point and length. So see, this is the point, the total distance from this is, let's consider small r. ठीक है? So theta explain केलेला आहे मी सांगते, and this r square is obviously the distance. Okay, I'll explain this permeability in tomorrow's lecture. First, now concentrate on this Biot-Savart. Permeability will explain करते हैं, ठीक है? Permittivity, permeability quite explain करून देते हैं. Yes. हाँ, तेच permeability explain करायचं. आधी हे explain करते हैं, मग permeability. So see, this is IDL sin theta upon I square. ठीक है? तो तुमच्या book मध्ये everything is explained well. What is this exactly theta? Now see, this diagram shows you very arbitrarily shaped of wire carrying a current I, where this small length, that is DL, is a length element along this wire. You can take this DL anywhere. Okay? The current in this element is in the direction of length vector DL. So this is the direction of current and also this is the direction of the length element. Okay? Let us calculate the differential field because this field will change at each and every point because of the length. Yes? Bol. This amount of a length DL. DL too जास्ती घेतला तर field will be greater because it is dependent on this length. Okay. Now net magnetic field at the point P, this any arbitrary point you can take anywhere on the left hand side also. It depends on the direction of the current and where you are taken your point. It can be obtained by superimposition of magnetic fields dB bar at that point due to various different length along the wire, but you have to take the whole wire after integration. Okay, because the field at this point will be due to the whole length of this wire. Next, this can be done by integrating, that is summing up of magnetic fields dB bar from these length element, and experimentally the magnetic field is given by this formula. So here this theta that is well explained here. It is the angle between direction of DL and R bar. So this is the direction of DL and this is the R bar. DL ची direction आणि R bar, this is your theta. Okay. Diagram, yes, diagram is given. This is the theta. Okay. Now see, this is your length element. Current element will be like this. Current element is I into DL. त्याला करंट इलेमेंट असं म्हणतात. करंट इलेमेंट इज अमाउंट ऑफ अ करंट फ्लोइंग इन DL अमाउंट ऑफ अ लेंथ. ठीक आहे. सो दिस इज द डायरेक्शन बिटवीन, दिस थीटा इज द अँगल बिटवीन लेंथ एलिमेंट अँड द डिस्टन्स आर. येस, काय तसा नाही येतो ऍक्च्युअली, मी याला झूम करून दाखवतो. इफ दिस इज द लेंथ एलिमेंट, मग त्यांनी त्याला असं एक्सपांड केलं. मी थोडं उलट घेते. This is the length element and this is your P, so this is your angle. एक्सपांड केलेला. ठीक आहे. इथे इतकाच थीटा नाही घेतात ना, आता मी लेंथ एलिमेंट वरती काढलेला. सो दिस इज आर्बिट्ररीली शेप्ड वायर. दिस मच अमाउंट ऑफ लेंथ इज DL. ठीक आहे. DL ला एक लाईन ड्रॉ केली प्रॉपर. सो दिस थीटा इज द अँगल बिटवीन लेंथ एलिमेंट अँड दिस पोझिशन और द डिस्टन्स ऑफ पॉइंट P फ्रॉम वायर. तो पॉइंट P चा डिस्टन्स कुठून घेणार? एक्झॅक्टली फ्रॉम द लेंथ एलिमेंट. एक्झॅक्टली फ्रॉम द लेंथ एलिमेंट. ठीक आहे. अँड म्यू नॉटच्या व्हॅल्यू बद्दल दिलं, इट इज 4.2 × 10⁻⁷. आणि जर तुम्हाला त्याची व्हॅल्यू माहिती पाहिजे नसेल तर यू कॅन सबस्टिट्यूट दिस 4 तर कॉन्स्टंट आहे. पाय विल बी 3.14. आफ्टर सबस्टिट्यूटिंग यू विल गेट म्यू नॉट इज 1.26 × 10⁻⁶. बट बेटर leave as it is because sometimes this pi will get cancelled. ठीक है, because तुम्हाला sin theta or current or length element is given in terms of a pi, so it will get cancelled out. Okay. Now the next direction of dp bar is dictated by the cross product. So here see, this is the sin theta. Sin theta ला remove करायचं असेल तर कुठला product घेणार? Dot product or cross product? क्रॉसला साइन घेतो, डॉटला क्रॉस घेतो. सो वी हॅव टू टेक द क्रॉस प्रोडक्ट. क्रॉस प्रोडक्ट or any vector product, obviously cross product is a vector product. It will be between two vectors. Am I right? Vectors means these are the two terms having directions. आता इथे directions कोणाकोणाला? I and DL is directed in the same manner, so theta will be 0. So this theta is not between the I and DL. It is between DL and R. So let's multiply and divide by R. So this dB I'm going to rearrange as mu naught upon 4 pi into I into DL R sin theta divided by R cube. ठीक है? That is equal to mu naught upon 4 pi I into DL bar cross R bar upon R cube. ठीक है? This is the small amount of magnetic field due to this amount of length. If this DL bar is total L, then the magnetic field will be D only. ठीक है? Crystal clear? What is crystal clear? Okay, see, so this is the magnetic field due to the length DL bar only. Now the equations, this and also this is the magnitude format and vectorial format मध्ये लिहिलं. Both these equations are actually same, फक्त इथं cross product मुळे R cube is there, but it is again inverse square law. So these both two equations are called as Biot-Savart's law or mathematical format of Biot-Savart law. Clear? Okay. So these two are your Biot-Savart law and you can conclude from this two as this is your inverse square law. Inverse square law means it is inversely proportional to the square of the distance. So previously कुठले inverse square law बघितलं तुम्ही? Gravitational force. Gravitational force is G(m)(m) upon R square. So this is inverse square law. Electrostatic force or Coulomb's force, you can say it is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Now this magnetic force, is it magnetic field? Magnetic field is mu naught upon 4 pi IDL sin theta upon R square. So these three are your inverse square law. Electric field is also there. So एकदा CET मध्ये question विचारेला, which of the following is not inverse square law? So which of the following quantity is not inversely proportional to the square of any distance, or you can say the position vector. Distance ला आपण position vector म्हणतो. Potential energy can be there. Potential energy is 1 upon 4 pi epsilon naught Q1 Q2 upon R only. Yes, and potential is Q1 upon R only. So potential is not inverse square law, it is inversely proportional to distance only. It is not the square of the distance. Okay, so this is your basic generalized Biot-Savart's law. Okay, integrate केलेला नाहीये कुठं. There is no any case here. Now we will see two cases. In that case, we will find out the total magnetic field over there. This is the magnetic field due to the length element, right? The first case is a key. Okay, see. So the first case is current in a straight wire. This is the first case for the magnetic field. Current. Okay, see. दोन cases घेऊया, then we will take the numericals or some basic questions regarding this Biot-Savart. So first is current in a straight wire. Okay, so current in a straight wire, or you can say the long straight wire, having length, let's say capital L. So in this section, we have to solve some mathematical formulation, that is integration. ठीक आहे, सॉल्व करून दिलेला डिटेल मध्ये राईट साइडला. आपण आता डेरिवेशन बघूया. नाउ सी, you are aware of the right hand thumb rule. Remember the right hand thumb rule. Hold your conductor in your right hand, outstretch your thumb in the direction of the current. So this curled fingers will give you the direction of the magnetic field. So the following diagram, that this I'm considering the wire here, let's say point P. I have to find out the magnetic field at point P, which is at a perpendicular distance of capital R from the long straight wire, and this wire, there is current I, its direction is upward. Clear up to this? Okay. Consider this length element here, and the angle from this here, आपण थीटा कुठे घेतो? लेंथ एलिमेंट पासून. लेंथ एलिमेंट आणि पोझिशन. आता हा लेंथ एलिमेंट असा येईल स्ट्रेट वायर. सो इफ दिस इज थीटा, दिस विल बी थीटा. मी एक्सप्लेन करते. कुठे घेतलं तर इथे घेतलं तर तो तर भेटणार आहे. आर्बिट्ररीली चालले. आपण जनरलाइज करणार आहे ना पूर्ण. येस. कुठे? वी आर कन्सिडरिंग दिस अँगल right now. Explain karte मैं आज. Now see, we want to calculate the magnetic field B bar at a point P, which is at a perpendicular distance, let's say capital R, from the wire. Now consider a current length element of infinitesimal length dl of the wire, and let I be the current passing through the wire situated at a distance r from the point P. Let's say this is at a distance of small r from point P. The product I into dl, this I into dl is called as current element, and I is the current passing through the wire. So using the equation of Biot-Savart's law, मी काय आपल्याकडे equation Biot-Savart's law चं, dB bar is equal to mu naught upon 4 pi I dl sin theta upon r square. ठीक है? So this is the magnetic field by Biot-Savart's law. Now here the direction of dB bar is given by cross product of dl bar cross r bar. So that is into the plane of the paper. dl bar ची direction कुठे? dl bar is this, cross r bar is this. It is like this. Right hand rule. Screwdriver असा move केला तर field ची direction कुठे येईल? It is into the plane of the paper. That is given over. So dl bar cross r bar, due to this the magnetic field direction of this will be into the plane of the paper. So whenever there is cross product, त्याची direction कशी काढणार? Like screw rule. So it is dl bar cross r bar, it will move like this. Screwdriver किंवा screw आतमध्ये जाईल, that is into the plane of the paper, the direction of magnetic field is. Now see, you have given the two important points. First, we now calculate magnitude of magnetic field produced at this point, we have considered this point P, by all current length elements in the upper half of infinitely long wire. We will do this by integrating equation. This wire is long straight wire. Long means its length is infinite. So firstly, we will calculate the field at this point due to upper half. ठीक है? कैसे calculate करना? By integrating this, obviously. Second, let's now calculate magnitude of magnetic field produced at this point P by similar current length element in the lower half of the wire, and by symmetry, obviously its magnitude and direction is the same as that due to the upper half. So magnetic field is again directed into the plane of the paper. So in order to find out the total magnetic field at this point, firstly we have to calculate field due to upper half, then due to lower half. As due to symmetry, it will be 2 into due to the upper half, right? एक काढलं तरी चालेल. Lastly फक्त we have to do 2 into the magnetic field. Okay? Now see, B bar will be 2 into dB bar, and integrate करताना upper limit and lower limit are from 0 to infinity. So see, therefore the total magnetic field at point P is 2 into integration of dB bar from 0 to infinity. Why 0 to infinity? Because they have given the wire is of long length, that is infinite length. ठीक आहे, मग 0 लेंथ पासून स्टार्ट केलं मीन्स इथून 0 पासून स्टार्ट केलं इन्फिनिटी, 0 पासून स्टार्ट केलं इन्फिनिटी, इट विल बी 2 into 0 to infinity. ठीक आहे, अदरवाइज तुम्हाला मायनस इन्फिनिटी टू इन्फिनिटी करावं लागलं असतं, ज्याचं येत नाही कॅल्क्युलेशन. ओके, नाउ द नेक्स्ट, जस्ट सबस्टिट्यूट दिस magnetic field value, that is 2 into integration of 0 to this mu naught upon 4 pi will be outside the integration sign, I dl sin theta upon r square. ठीक आहे, आता इथं dB का लिहिलेलं आहे? बिकॉज वी हॅव लिमिट्स ओव्हर हियर. आता आपण इंडेफिनाइट इंटिग्रेशन पाहिलं ना, सो इन बघितलं ना इंडेफिनाइट इंटिग्रेशन, त्याच्यामध्ये आपण लिहित होतो इंटिग्रेशन ऑफ x into dx, because we don't have the limits from where up to where we have to integrate the whole. Here we have limits, so we don't have to write over the dB bar, dx bar, dr bar. कशाचीच गरज नाही. नेक्स्ट काय सबस्टिट्यूट करणार? काही अजून कॉन्स्टंट निघतं बाहेर? These are only constant. I, yes, I can be constant. ठीक है, so it will be mu naught I upon 2 pi, चालेल, 2 2s are 4, integration from 0 to infinity dl sin theta upon r square. Clear up to this? आता बुक मध्ये बघा. From this whole diagram, if this is the length, small length, आपण त्याला तिथून distance consider केलेलं आहे. So from this you have R is equal to root of L square plus R square. ठीक है, फर्स्ट टर्म समझ ली. देन साइन थीटा, दिस इज द थीटा. साइन थीटा इज साइन ऑफ 180 मायनस थीटा. आतमधला थीटा पाहिजे ना. इट विल बी साइन ऑफ पाय मायनस थीटा. साइन ऑफ पाय मायनस थीटा कुठला येईल? थीटा, जस्ट अ मिनिट. From this formula, this theta is this one. So sin theta will be sine of pi minus theta. Repeating. From this formula, theta is the angle between this and this, right? From inside. Okay. So this is sin theta, ha itla theta. We have this theta. We upon introduce केलेला है for long infinite straight y. Okay. So for this one, sin theta will be sine of pi minus theta. So we have sin theta, that is sine 180 minus theta, that is, this will be, sin theta is opposite upon hypotenuse, that will be opposite upon hypotenuse, that is equal to r divided by, this r is in square root L square plus R square. इथपर्यंत clear है? Now we have integration. हे substitute करते. We'll get B magnetic field is equal to mu naught I upon 2 pi integration of dl. Okay, sin theta is r upon root of L square plus R square into R square. पुढे काही नाही. ठीक है. Now see, root of L square plus R square is R. L square plus R square is R. महा R square direct असेल raised to 1 only. R square ला लिहू असं. L square plus R square. लिहू सकते? It will be mu naught upon 2 pi integration R upon L square plus R square raised to 3 by 2 from 0 to infinity it is always into dl. चालेल? So this is the integration of R upon L square plus R square raised to 3 by 2. This integration, the whole answer of this integration is 1 upon R square. आता हे मी जर तुम्हाला सांगितलं एक्सप्लेन करून तर आपलं अजून इंटिग्रेशन झालेलं नाही. ते प्रॉपर्टी कुठले समजणार नाही. पेज नंबर 241 बघा. So this integration you can solve by the method of substitution. What you have to substitute is L is equal to R tan theta. So by substituting you will get this whole. Solve करायचं integration. फक्त एक substitution सांगते. We will solve the whole integration. इथपर्यंत लिहून घ्या शॉर्ट मध्ये. इम्पॉर्टंट आहे खूप. मी रिवाइज करते अजून एक. येस. तो त्यांनी इंट्रोड्यूस केलेला आहे. दिस इज द अँगल बिटवीन द करंट एलिमेंट अँड द पोझिशन. कुठे? If this is theta, this will be pi minus theta. मग त्यांनी तोच लिहिलेला आहे. अँड साइन 180 मायनस थिटा इज साइन थिटा, सो यू कॅन टेक इट पॉझिटिव्ह. तो आतमध्ये पाहिजे ऍक्च्युली थिटा. कर. लिहून घे ना. हा, रफ मध्ये. बायट-सावर्ट्सला. सॉल्व्ह करणार आहे इंटिग्रेशन पूर्ण. Actually, substitution method is in indefinite integration, but you have also given the limits. So फक्त लास्ट स्टेप मध्ये सबस्टिट्यूट करायचे लिमिट्स. येस, इथे काय होतं, आर स्क्वेअर इट इज एल स्क्वेअर प्लस आर स्क्वेअर. सो इट इज रेस टू 1/2 प्लस 1, that is रेस टू 3/2. झालंय. सी, we have magnetic field B bar is mu naught I राहिला, mu naught I, this R is also constant. ठीक है, R, this distance is also constant, R divided by 2 pi, and the integration is from 0 to infinity. What left is dl divided by L square plus R square raised to 3/2. So we will solve this integration. ठीक है, I is equal to integration from 0 to infinity dl upon L square plus R square raised to 3/2. Substitution method ने solve करना है. Substitution तसा का केला, we will see in the integration in very detail. So we have L is equal to R tan theta. Actually, we need the relation between L and R. So see this diagram. This is theta, this is L, this is R. So according to this theta, this is adjacent, ऑपोजिट ऍडजसंट दिस इज युअर हायपोटेनियस, म्हणून तुम्हाला हा थिटा घ्यायचा, दॅट इज युअर पाय थिटा. सो टॅन थिटा इज एल अपॉन आर. आतला जर थिटा घेतला तर एल अपॉन आर व्हायलेट होत आहे ना, येत नाही ना रिलेशन, म्हणून हा एक्सटेंड करून थिटा घ्यायचा, म्हणून त्यांनी सबस्टिट्यूशन असं घेतलेलं आहे, एल इज इक्वल टू आर टॅन थिटा. या सबस्टिट्यूशननेच ते पूर्ण सॉल्व्ह होणार. हा थिटा घेतला ना, इट विल बी कॉस ना. कसा येणार एल इज इक्वल टू आर टॅन थिटा? सबस्टिट्यूट कसा करणार? कॅपिटल आर येतोय, असं पण होऊ शकतो. ऍडजसंट टॅन थिटाचा फॉर्म्युला काय? ट्रिग्नोमेट्री, ऑपोजिट अपॉन ऍडजसंट और ऍडजसंट अपॉन ऑपोजिट. पण नाही येत, कॉट थिटा येतो मग तो. कॉट थिटा टाकलं तर नाही होणार. ठीक आहे, ट्राय करून बघू आपण या सबस्टिट्यूशन. एल इज इक्वल टू आर टॅन थिटा. सो दिस विल बी 0 to infinity. याला डिफरन्शिएट करा. If L is equal to R tan theta, then dl will be R is constant. Tan theta चे डेरिव्हेटिव्ह sec square theta d theta. ठीक आहे. सो सबस्टिट्यूशन्स केले. वी हॅव टू चेंज लिमिट्स ऑल्सो. लिमिट्स पण चेंज होणार. दीज लिमिट्स वर फॉर dl. नाउ द लिमिट शुड बी फॉर थीटा. थीटा 0 to infinity चा कसा टाकणार? So we have to change the limit. If lower limit is 0, if L is equal to 0, L ची व्हॅल्यू जेव्हा 0 येते तेव्हा तुमचा dl आणि r theta सबस्टिट्यूट केल्यावर थीटा काय येईल? L equal to 0 टाका. You will get r theta, r tan theta is equal to 0. So tan theta is equal to 0. Theta will be 0. इथं लिमिट्स L साठी होतं, आता लिमिट्स थीटा साठी. Upper limit is infinity. If L is equal to infinity, r tan theta will be infinity. So tan theta will be infinity. Theta will be, tan ची कुठली व्हॅल्यू इन्फिनिटी? पाय बाय 2. पाय बाय 2. केले लिमिट्स चेंज. नाउ द न्यू इंटिग्रेशन इज फ्रॉम 0 to पाय बाय 2. सबस्टिट्यूट करतोय सगळं. dl is r sec square theta d theta whole divided by L square as it is. L square काय येईल? L square will be r square tan square theta plus r square raised to 3 by 2. येस, दोज लिमिट्स वर फॉर लेंथ. आता लेंथ वरतून थीटाची लिमिट चेंज होणार. हे सबस्टिट्यूशन मेथड मध्ये खूपदा करणार आहे. दिस इज क्वाइट न्यू फॉर यू. ठीक आहे, आता ह्याचा पुरतं सांगून ठेवतीये फक्त. तुम्हाला क्वेश्चन येऊ शकतो की कसा आला एक्झॅक्टली. क्लिअर आहे? नेक्स्ट 0 to पाय बाय 2 r sec square theta d theta. याच्यातून काय कॉमन येईल? r square. r square पण त्याला पॉवर पण आहे, विसरायचा नाही. रेस टू 3 by 2. आणि ब्रॅकेट मध्ये राहिलं 1 plus tan square theta रेस टू 3 by 2. काय डाऊट आहे इथपर्यंत? 2 काय राहिलं? What is left here? 0 to pi by 2 r sec square theta d theta divided by r cube. 1 plus tan square theta चा काय फॉर्म्युला आहे? नक्की 2 कॅन्सल होणार ना? आहे ना? नाही काय केलं अजून, करायचंय ते चालू आहे. 1 plus tan square theta नक्की. जर इथं सेक स्क्वेअर थिटा टाकला, स्क्वेअर स्क्वेअर रूट कॅन्सल येईल, सेक क्यूब येईल. ठीक आहे, बुक मध्ये खूप लेंदी दिलंय. दिस विल बी सेक स्क्वेअर थिटा रेस टू 3 by 2. कळालं काय केलं? सो 0 to पाय बाय 2 एक एक आर गेला, वरती राहिला सेक स्क्वेअर थिटा अपॉन आर स्क्वेअर. इथे 2 कॅन्सल, इट इज सेक क्यूब थिटा डी थिटा. समजतंय? हा आर स्क्वेअर बाहेर येईल. 1 अपॉन आर स्क्वेअर integration from 0 to pi by 2, square cancel, it will be 1 upon sec, that is cos theta d theta. झालं simplified format मध्ये. cos चं इंटिग्रेशन sure, cos चं मायनस साइन डेरिव्हेटिव्ह आहे, इंटिग्रेशन पाहिजे. इट इज प्लस साइन theta and the limits are 0 to pi by 2. What is the role of this limits? You have to substitute upper limit, that is sin pi by 2 minus lower limit, that is sin 0. हे इंटिग्रेशन एक्झाम मध्ये सॉल्व्ह करायचं नाहीये. दिस इज फॉर युअर अंडरस्टँडिंग ओनली. ठीक आहे, हे केलं तर याला 4 मार्क द्यावे लागतील. sin 90 is 1, sin 0 is 1 minus 0 1 into 1 upon r square. कळालं कसं आलं? त्यांनी ना इथे आपण डायरेक्ट लिहिलं ना आयडेंटिटी, त्यांनी tan स्क्वेअर ला केले sin स्क्वेअर अपॉन cos स्क्वेअर, मग क्रॉस मल्टिप्लाय, मग त्याला वरती टाकलंय, मग sin स्क्वेअर थिटा प्लस cos स्क्वेअर थिटा इज इक्वल टू 1, 1 raised to 3 by 2 is 1, इतकं केलंय. इफ यू डोंट नो द आयडेंटिटी. ठीक आहे, सो दिस इज द इंटिग्रेशन 1 अपॉन r स्क्वेअर. सबस्टिट्यूट करायचा. येस, करून बघा तेव्हा इंटिग्रेशनचा आन्सर आलं पाहिजे. ठीक आहे, सो दिस इज द व्हॅल्यू ऑफ दिस इंटिग्रेशन. लेट सबस्टिट्यूट. आर नव्हता हा याच्यामध्ये, आर नव्हता, आर बाहेर होता. सांगते ना. सो देअरफॉर ओके, इथला का दुसरं सबस्टिट्यूशन करायचं. सबस्टिट्यूशन करून बघा, काही प्रॉब्लेम नाही. एलच्या टर्म्स मध्ये नाही पाहिजे, नंतर रिअरेंजमेंट करू शकतो ना एल आणि आर ची, परत ट्रिग्नोमेट्री यूज करायचं. सो सी दिस बी बार इज नाउ म्यू नॉट आय आर अपॉन 2 पाय and the value of this integration 1 upon r square. एक r cancel, answer is mu naught I upon 2 pi r. This is the only one case we have, Biot-Savart's law. This is the magnetic field due to a current in a long, means infinite straight wire, that is mu naught I divided by 2 pi r. स्मॉल r वरती डिपेंड आहे, डझंट मॅटर कुठे लेंथ एलिमेंट कुठे करंट एलिमेंट घेतलाय, कुठे पण घेऊ शकता. ठीक आहे, स्मॉल r च्या टर्म्स मध्ये आन्सर येतच नाही, इवन देयर इज नो एनी स्मॉल l ओव्हर देयर. सो त्याची पोझिशन डझंट मॅटर. व्हॉट मॅटर्स इज व्हॉट इज द डिस्टन्स ऑफ दॅट पॉइंट फ्रॉम द करंट कॅरिंग वायर. सो द आन्सर इज म्यू नॉट I upon 2 pi r. ठीक आहे, this is the most important formula for your MCQ solving. Okay, this is for infinite long straight wire. They are interested in semi-infinite. Semi means this infinity is about infinite length. Infinite length. Semi-infinite is इथपर्यंत length fixed आहे, इथून किती वाढते माहिती नाही. समजतंय? It is fixed at one end, but it is infinite at another end. So you just have to divide this by 2 because we have already multiplied it by 2 for the upper half and lower half. So for semi-infinite, this will be B for semi-infinite is equal to mu naught I upon 4 pi r. You can directly write this. Mu naught I upon 4 pi r. Clear है? This is the Biot-Savart's law. कुठल्या काही टॉपिक मध्ये तर डाऊट आहे? डायग्राम मध्ये डेरिव्हेशन नाही घ्यायचं तुला, म्हणजे बुक मध्ये लिही पण एक्झाम मध्ये नाही घ्यायचं. फॉर्म्युला माहित पाहिजे पण कंपल्सरी. ठीक आहे, फक्त ते थीटा एकदा परत जरा बघून घे. दुसरी कुठली डायग्राम आहे का त्यांच्या बुक मध्ये बघू आपण. तुमचं ज्यांचं झालंय त्यांनी हे लिहून घ्या, मी एकदा तो थीटा चेक करते.